Problem 11. Consider a thin-walled cylindrical tube having a radius of 65 mm that is to be used to transport pressurized gas. If inside and outside tube pressures are 101 atmosphere, which are equivalent to 10.13 and 0.1013 megapascal respectively, compute the minimum required thickness for each of the following metal alloys. Assume a factor of safety of 3.5. So in part A we need to find the thickness of the tubes in case if we make these tubes by these alloys. So based on the properties of these alloys, the thickness will vary. And in part B, a tube constructed of which of the alloy will cost the least amount. So that is part. So for part A, we need to know the thickness. The relationship or the equation for the thickness is equal to n times the radius times the change in pressure. Okay, and divided by yield strength. So n is equal to 3.5. Okay, and r is the internal radius. Okay, and delta p is the change in pressure. So n is 3.5, factor of safety. Internal radius is 65 millimeters, so it should be 65 millimeter, and multiplied by the pressure, change in pressure, outside pressure 10.13 minus the inside pressure 0.1013. So if I calculate it, then its value will be 2281.5 megapascal millimeter. Okay, so now we can apply this thickness equation for each of these alloys. So for example, T steel, okay, plain, that will be equal to this value 2281.5 divided by its yield strength, which is given as 375 megapascal. So remember that its units were megapascal millimeter, and then we are dividing it with megapascal. So megapascal cancels with megapascal, and then we will get a answer directly into millimeter. So it will be 6.08 millimeter. Similarly, you can find the thickness for alloy steel. So 2281.5 divided by its yield strength, which is 1000. So in this case, since the yield strength is much higher, so it will be only 2.28 millimeter. And similarly, the thickness for cast iron, by the same formula, you will find, okay, I don't need to write it over here, so let me see. It will be, okay, so it will be 2281.5 divided by 225. So its yield strength is much lower, so its thickness should be much higher, so 10.1 millimeter. So it should be 10.1 millimeter. Okay, thickness. For aluminium, it will come out to be 8.3 millimeter. So because its yield strength is much higher than the cast iron. Magnesium yield strength is much lower, and its thickness is the most. Thickness needed for this is more 13.0 millimeter. So by the same approach, aluminium, it will be 2281.5 divided by 275, and then like that. Okay, so now we have found the thickness for each one. So it means that we have completed part A, and then you can see that the minimum thickness needed is for steel alloy. Okay, steel alloys, but it is also the most expensive one. No, not the most expensive is magnesium. Anyway, let's see uh, uh, part B. Okay, so for part B, need to find the material cost for each of these materials. So material cost will depend on the uh, unit cost, okay, per kilogram. So this means that we should have we should know the quantity of each material. Okay, so for example, and then we have been also given as the density. So density, we know that density is equal to the mass per volume. Okay, so if the density is represented by rho, mass is represented by, say, m, and volume is represented by v. So we know the density, and the cost is based on the mass. So cost is equal to total cost is equal to the price. So basically this is the price. Okay, if you see that, if you can represent it with price, okay, P. So P, price per mass multiplied by the mass. So here I think if we want to find the cost, price we already know, mass we need to find from here. Mass is equal to the density multiplied by the volume. So we need to find the mass, then we need to know the volume. But how we can find the volume? Okay, so this is another issue. Anyway, but let me tell you, because this is the tube, okay, a thin tube, and we need its volume, and the tube has a thickness, okay, T, and the tube has its internal radius r. So if we know this T and we know this radius r, so from the geometry of this equation, and then we know that its length is like L, okay, it's about uh, L meter long, this tube. So this is the diameter, that means 2 times the radius. This is the thickness, that means this much is the thickness. So if we know the length, then the thickness, then the radius, then we can find the volume by this equation, pi times 2 r t plus thickness square multiplied by length. So remember that r is the internal radius, okay, t is the thickness. Well, it's you can use your knowledge of geometry to derive this formula. Okay, I'm not going to the derivation of this formula over here. So we can find the volume of each material. So in this, we know that for each material only the thickness is changing. So you can find the volume of plain steel first, okay, and then volume for other materials. So let's find the volume of the plain steel. Volume of the plain steel is pi times 2 times r. R is equal to 65 millimeter. And convert it into meters. So times minus 3 meters 2r, and then thickness we already found, so thickness is 6.08 millimeter times 3 plus thickness is 6.08 minus 3 square, and then close it. So it's a long expression. So it will be equal to but for this I think I need to specify about the length. So since the length is not specified, so you can take it as equal to 1 meter. So that means that all the values will be based on a 1 meter length, so which is okay, which we can, since we can compare these materials based on their 1 meter length, so take it as 1 meter. So in this case then it will be 0.002601 cubic meter. So from this volume then you can find the mass or the quantity. Okay, so the quantity we can find now 0.002601, multiply its density. Density is given as for the steel, the density is given as 7.8 gram per cubic meter. Okay, gram per cubic centimeter. Okay, and we need to use kilogram per cubic meter, so we know that 7.8 gram per cubic meter is equal to 7,800 kilogram per cubic meter. For example, if you convert from gram per cubic centimeter to kilogram per cubic meter, so you can easily see that you need to multiply this gram per cubic centimeter by 1000. Okay, so multiplied by 1000, so this will give us an answer of mass in kilogram, which will be equal to in this case 20.29 kilogram. So remember that this is the mass for needed for steel for 1 meter length. Okay, so from this mass now you can find the cost you can multiply find by the price. 20.29 kilogram is the mass needed, and multiplied by the unit cost, which is $1.65 per kilogram. So $1.65, so it will be 33.48 dollars. Okay, per kilo per meter length. Okay, so per meter length. Okay, $3.48. So in this way you can repeat it for other materials. So the only thing change over here will be the thickness. Okay, in the same formula, so thickness value will be changed, so volume will be changed, and then this volume will be multiplied by its respective density and the cost. So you will get the volume for alloy steel. Okay, then you will find the mass for alloy steel, and then you will find the cost for alloy steel. So since the calculations are similar in nature, I will not show these calculations over here. So let me just write down the final answers for the total cost. So this will be 33.48, as I have already calculated in dollars. Okay, this will be 29.58, that is the alloy steel, and the cast iron will be much expensive, $79.24, because we need it very thick compared with the other materials. And aluminium will be a little bit cheaper, $72.99 per meter, and the magnesium is most expensive at $158.18. So the cheapest material to use is the steel alloy. Okay,